concentrate on the exam questions in terms of first order differential equations. So if you don't know anything, I would suggest that this is just a summary, and therefore I'll just talk about some things that are pretty useful in exams. And so to start off, there are 5 types of first order differential equations. Alright, this is from what I've just learned. Alright, so definitely the first one is separable equations. If you don't know anything, this is very easy. You just go and click this link and just check it out. Alright, it's from Khan Academy, after which you can just come back here and continue. Alright, the next method is y equals to a kt method. Alright, this is the second one, so I'll just talk about it later in this video. And then substitution, we will talk about it in the next video, because there's a lot of things in there. And then exact, you just click this video. I've gone through it in the previous parts already. So if you don't know anything, you just click this link and just check it out. Alright, integrating factor. Alright, this is something also a bit confusing in terms similarly to substitution, but I'll just try to make it easier, because I've repeatedly do this type. Anyway, so so without further ado, let's just start off with these two things first. So I've gave link to this one and this one. So I just need to finish off these two things, and the next video we'll just finish off this one. Alright, and therefore a typical y equals to a kt question is find dy dt is equals to 4y, for example. Find y, and therefore the proposed solution is that aekt is equals to y. Alright, later on you'll know why y is equals to aekt. Alright, so to solve, you just treat this as k, and the answer is just ae4t. That's it. Alright, if you wonder why, alright, I'll just call you to differentiate this term. Alright, differentiate this term means dy dt is equals to, if I differentiate, I take out the coefficient 4, so I have 4 times ae4t in this case, right? And this is in fact y, so dy dt is equals to 4y, which is this one, the question. So the solution, definitely, as you can see, if I were to derive from here, this is the solution, ae4t. So just to lock things into deeper way, if I have minus 1000y, what is the answer? Then you just simply take this as k. So we have ae minus 1000 t, and that's it. This is the answer, is equals to y. And just be mindful that there are many variations in terms of how they set up the questions. They may set up like dy dt plus 1000y is equals to 0. So you're gonna bring this over here, and then it becomes like that, and then you solve using what the method I've just showed you just now. Alright, and there may be other variations also, and so please be careful on how to identify the type of questions that may come out in exams. Alright, so now let's talk about integrating factor. Normally this is more on the higher mark question, alright, but normally if they just ask you to solve for an integrating factor, when you see this, you may be tempted to say that this is a exact equation. Alright, but think again, just look properly, this is not exactly exact equation. Alright, because there's somewhat clean over here. If you have some, but I would suggest that, anyway, first thing first, you have to you have to ensure that the coefficient here is empty. Alright, and then also that, how do you identify integrating factor? Alright, I will assume that you know exact equations already. So for example, exact have some like 2x plus 3dx a dy plus b3 3xy dy a dx equals to 0, right? Just something like that. You find it how do I say familiar, is that you have to solve using exact. So you need to just check whether are they exact. Is this exact or not? If they are not exact, this means that you're gonna solve using integrating method. Alright, but in terms of how to identify, alright, in the test exam they wouldn't be that tricky to give you like similar to exact type of questions. but they will actually give you something like coefficient here is like 1, right? So there is like there's like not 3 nor 4 or whatever, like, or something like y square over here. Normally they don't do that. If they do that, then be very careful also, right? But this type of question generally is integrating factor. Just soon you'll realize how to recognize. Alright, from here on I can't actually say much, but you should be able to identify. That's one thing that I want to convey. Right, so to just start off with things, normally the first thing I'll identify is y is the numerator. This is y, and therefore the next one I'm going to identify is y is the coefficient besides y. Alright, so this is the y, so the coefficient is minus 2x. Right, are there any coefficients? I don't think so over here. These are all x's, and therefore I can assume that these are something that we don't need now. Alright, so the first thing first, identify what is the numerator first, y. So find the next y to the power of 1, meaning just y itself lah. Alright, and then just check it out, the coefficient. So I can just simply rewrite this as dy dx plus minus 2xy. Alright, so I'm just simply rewriting this as minus 2x in terms of this thing over here. I call this p. Alright, and I'm going to introduce you to integrating factor p dx. In this case, this thing is going to be the denominator one. So when identifying where to take the p, you're gonna find the y first. Alright, find the numerator, and then once you find the numerator, find the denominator. It's like settle the top and then settle the bottom type of thing. Alright, so just sub in this as dx, because in the test normally they don't give you this thing. You need to also set up your own equation, and so therefore I know that my p is minus 2x in this case. So therefore I have e minus 2x dx. And assume that you are somewhat good at integrations already, and therefore this is just simply minus x squared. Alright, minus 2x, integrate, you'll just get minus x squared. That's the thing lah. Alright, this is the integrating factor. We call it IF. Sorry. So how do I integrate, how do I so-called implement this integrating factor? Alright, so I'll just clean up things a bit. This is the initial equation, right? The one that I've been given, just that I just set it as this one first, right? And therefore the integrating factor is just a factor multiplied into the whole thing. So I'm just multiplying into all individual terms. Alright, I'm just multiplying them into all these individual terms. And what I would have is, after multiplying in, I'll have all these terms over here. Alright, the next thing I'm gonna do, be very attention now. I mean, please pay attention, or whatever that attracts your attention, you know. But just check it out, this thing. Alright, what is the differentiated form of this one if I require you to differentiate this thing? Alright, you would have minus 2x e minus x squared, right? The first thing first you need to do is to differentiate this thing and find which term is similar to this thing that you have just differentiated. Do you find that this thing is similar to what you have just differentiated? And what is not similar is that you have an extra y over here. And therefore take out this y, put it over here, and then take out this thing that you have just differentiated, just put it over here. And this is simply your answer for both of this term. Alright? Because this is simply product rule. Because if I were to differentiate in terms of x, I would have dy dx. I differentiate this thing, and then I keep this thing. I have e minus x squared plus, and then now I differentiate this one. I will have minus 2x e minus x squared, and then multiply by, I keep this one as y. and this is exactly the same as this form. Alright, so this is the proof to show that this is the solution to the both of these terms over here. Alright, so this thing comes from here. Alright, comes from this thing. So I'll just clean up a little bit because this is very messy. And therefore I can just simply rewrite this as y e minus x squared. The whole thing differentiated in terms of dx. Alright, and it should be fine. Alright, so the first thing first, I will highly recommend you just go and identify this, your integrating factor, differentiate it, and then find the terms that is very similar to what you have just differentiated. And then whatever that is outstanding just is the one that is your final thing. Alright, please be very careful. I repeat again, just repeat again. Take this thing, differentiate one time, and then find whatever equation that is similar to what you have just differentiated. In this case is minus 2x e minus 2x squared. Minus x squared. In this case, the one that is nearest to what you have just differentiated is this one. Right? It's just the outstanding y. Then just take out the y and then keep your integrating factor, and this is your answer for both of this term. Right, you need to identify how it goes because it's just simply product rule. Alright, it's simply product rule. It is product rule. So sometimes you need to find ways to practice your product rule integration. Alright, you need to know how to identify. And then maybe perhaps, I think you just write it down, like for example TET, and then I ask you to differentiate this, you will have ET plus TET. And therefore I want you to find the solution if I were to ask you to integrate this one. Then you should get back this one because this is just simply product rule, right? So I want you to be very familiar with all these terms so that at least you know how the product rule works. And therefore when it comes to this, at least you are pretty much clear of all this. And therefore I just rewrite this thing and then I keep d over dx, because when you differentiate in terms of dx, you'll get back this term. Alright, because I didn't call you to integrate I just call you to rewrite this thing in terms of this thing. Alright, which is equals to the rest of this, I'll just copy and paste it over here. Alright, which is in terms of these things. Okay, and therefore I just rearrange. Alright, I rearrange this one because I can just say that dy dt now, because y can just bring it over to the d, right? E minus x squared is equals to 2x cubed. This is not the dt, this is dx. What am I doing? Plus 4x. Alright, so I'll just cancel out all the term because they are all the same. Alright, and therefore what I would have left is dy dx equals to 2x cubed plus 4. Alright, now I can finally integrate things in terms easily, right? Using separable method. So this is why I say separable is the easiest, because everything uses separable in the end later on. Not everything, but some things. So I would have y is equals to, if I were to integrate, I would have half x4 plus 4x plus c. So your answer is this form. And that's the answer. And don't forget, the question asks you with y when x is equals to 0. Alright, this thing y bracket 0 is simply say that when x is equals to 0. So therefore, taking this assumption, alright, when x is equals to 0, this all are 0, we know that it is equals to 10, right? And therefore we know that y is equals to just c, right? Because this becomes 0, 0 when x is equals to 0, that right? And therefore c is equals to 10, right? And that's it. So we have the final equation of half x4 plus 4x plus 10 equals to y, and that's the answer. And definitely this is not that easy. In tests sometimes this may not be that straightforward. So the key idea I want you to know is that you need to first identify what is the numerator first, the y, and then find your integrating factor. Alright, once you find your integrating factor already, alright, multiply it in, and then identify what is the differentiated form of the integrating factor, and then find something that is similar to it, get out the outstanding one, and then, or in other words, try to identify the product rule type of things. And the last thing is that be very careful of this thing, d over dx. This is very important. Alright, you're gonna put it in terms of this way. Alright, and then subsequently, if you have y over here, just rewrite it as dy dx. Alright, I hope that this helps you a lot. Next video we'll talk about substitution, and I shall see you there.